According to the National Electrical Code, specifically the 1999 edition, Article 406.3 states that all receptacles installed in dwelling units shall be grounded. Furthermore, Article 406.12 mandates that every receptacle outlet shall be connected to an equipment grounding conductor. This means that every electrical socket should be grounded and connected to an equipment grounding conductor, commonly referred to as a ground wire. Additionally, the socket should be securely mounted to a metal box, which provides an additional ground path. If there is no ground wire and the socket is not connected to a metal box, it is not compliant with electrical code requirements. An ungrounded or improperly grounded electrical outlet can create a significant electrical hazard. This can lead to electrical shocks, fires, and damage to electrical devices. Landlords are legally responsible for ensuring that their rental properties comply with all applicable building codes, including electrical codes. If an electrical socket is found to be non-compliant, it is important to take action. Firstly, inform the landlord of the non-compliant electrical socket and request immediate repairs. Secondly, if the landlord fails to address the issue promptly, you can contact the local building inspector or a licensed electrician to inspect the electrical system and issue a report. It is important to address the issue to mitigate any potential risks. The absence of a ground wire means there is no low resistance path for fault current to flow back to the electrical panel. In a properly grounded system, if a fault occurs, such as a live wire coming into contact with a metal appliance chassis, the fault current will flow through the ground wire back to the source, tripping the circuit breaker or blowing a fuse, thereby cutting off the power and preventing a dangerous shock. Without a ground wire, the metal chassis can become energized, posing a significant shock hazard to anyone who touches it. The purpose of the metal box is twofold. Firstly, it provides a secure mounting point for the receptacle, and secondly, it serves as an additional grounding path. The metal box should be grounded by connecting it to the equipment grounding conductor. This ensures that any fault current that may flow to the box is safely conducted back to the electrical panel, tripping the breaker. When a receptacle is hanging loosely from the wall, it is not only a safety hazard but also an indication of improper installation. The receptacle should be securely fastened to the metal box using screws or other appropriate hardware. This ensures that the receptacle is properly grounded and that it cannot be easily pulled out of the wall, exposing the wires. The National Electrical Code establishes minimum safety standards for electrical installations. These standards are designed to protect people and property from electrical hazards. Local jurisdictions often adopt and enforce the NEC, sometimes with local amendment. It is important to be aware of the electrical codes in your area and to ensure that your electrical system complies with these codes. Regular electrical inspections can help to identify potential hazards and ensure that your electrical system is safe. If you are unsure about any aspect of your electrical system, it is always best to consult with a licensed electrician. Electrical work can be dangerous and should only be performed by qualified professionals. If a landlord is unresponsive, contacting the local building inspector can initiate an official investigation into potential code violations. The building inspector has the authority to issue warnings and fines and can require the landlord to make necessary repairs to bring the property up to code. This can be a more effective way to ensure that the electrical issues are addressed promptly and effectively. A licensed electrician can perform a thorough inspection of the electrical system to identify any code violations or safety hazards. They can also provide a written report that can be used to support a complaint to the landlord or building inspector. An electrician can also make the necessary repairs to bring the electrical system up to code, ensuring that it is safe and compliant. If an appliance is not grounded properly, this can cause a ground fault, which can result in a dangerous electrical shock. Ground fault circuit interrupters, or GFCIs, are designed to protect against ground faults. They work by monitoring the current flowing in the circuit and tripping the breaker if they detect any leakage current. GFCIs are required in areas where there is a high risk of water exposure, such as bathrooms, kitchens, and outdoor locations. They can be installed as receptacles or as circuit breakers in the electrical panel. An arc fault is a dangerous electrical condition that can cause fires. Arc faults occur when electricity jumps between two conductors, creating a high-temperature arc. Arc fault circuit interrupters, or SIs, are designed to protect against arc faults. They work by monitoring the current flowing in the circuit and tripping the breaker if they detect any arc faults. SIs are required in many areas of the home, particularly in bedrooms and living areas. The National Electrical Code is updated every 3 years to reflect new technologies and safety standards. It is important to stay up to date on the latest code requirements to ensure that your electrical system is safe and compliant. You can purchase a copy of the NEC from the National Fire Protection Association, or NFPA, or you can access it online through various subscription services. Many local jurisdictions also provide access to the NEC through their websites. Electrical safety is a shared responsibility. By being aware of the potential hazards and taking steps to protect yourself and your property, you can help to prevent electrical accidents and injuries. If you have any concerns about your electrical system, it is always best to consult with a licensed electrician. They can provide expert advice and assistance to ensure that your electrical system is safe and compliant. In older homes, it is common to find ungrounded receptacles. However, it is important to understand that these receptacles do not provide the same level of safety as grounded receptacles. If you have ungrounded receptacles in your home, there are several options you can consider. Firstly, you can replace the ungrounded receptacles with GFCI receptacles. GFCI receptacles provide protection against ground faults, even if they are not grounded. Secondly, you can install a ground wire to the receptacle. This is the preferred option, as it provides the best level of safety. However, it can be more expensive and may require the services of a licensed electrician. Thirdly, you can replace the 2-wire wiring with 3-wire wiring. This is the most comprehensive option, as it replaces all of the ungrounded wiring in the home with grounded wiring. However, it is also the most expensive option and may require significant renovation work. When working with electricity, it is important to take precautions to protect yourself from electrical shock. Always turn off the power at the breaker before working on any electrical circuit. Use insulated tools and wear rubber gloves to protect yourself from shock. Never work on electrical circuits when you are wet or standing in water. If you are not comfortable working with electricity, it is best to hire a licensed electrician. They have the knowledge and experience to perform electrical work safely and correctly. In addition to the National Electrical Code, there are other codes and standards that may apply to electrical installations. These include the National Electrical Safety Code, or NESC, which covers electrical installations outside of buildings, and the International Building Code, or IG, which covers the structural and fire safety aspects of buildings. It is important to be aware of all of the applicable codes and standards to ensure that your electrical installation is safe and compliant. Electrical systems can deteriorate over time due to corrosion, loose connections, and other factors. Regular maintenance can help to identify and correct these problems before they lead to more serious issues. Maintenance tasks include inspecting wiring for damage, tightening loose connections, and testing GFCI receptacles. It is recommended to have your electrical system inspected by a licensed electrician every few years to ensure that it is in good condition. Power surges can damage electronic equipment and appliances. Surge protectors are designed to protect against power surges by diverting excess voltage to ground. It is important to use surge protectors on all sensitive electronic equipment such as computers, televisions, and stereos. Surge protectors are available in a variety of types, including power strips, wall-mounted units, and whole-house surge protectors. Whole-house surge protectors are installed at the electrical panel and provide protection for all of the electrical circuits in the home. Electrical fires are a serious hazard. They can be caused by faulty wiring, overloaded circuits, and other factors. If you suspect an electrical fire, it is important to evacuate the building immediately and call the fire department. Never use water to extinguish an electrical fire, as water is a conductor of electricity. Instead, use a fire extinguisher that is specifically designed for electrical fires. Smoke detectors are essential for detecting electrical fires early on. They should be installed in every bedroom and on every level of the home. Smoke detectors should be tested regularly to ensure that they are working properly. Replace the batteries in your smoke detectors at least once a year. Carbon monoxide detectors are also important for detecting carbon monoxide, a deadly gas that can be produced by faulty appliances. Carbon monoxide detectors should be installed near sleeping areas. They should be tested regularly and the battery should be replaced at least once a year. It's important to remember that electricity travels in a circuit from a source to a load and back again. The source is typically the electrical panel, and the load is any device that uses electricity, such as a light bulb or an appliance. The wires in the circuit carry the electricity from the source to the load and back again. If there is a break in the circuit, the electricity will not flow. This is what happens when a circuit breaker trips or a fuse blows. Circuit breakers and fuses are designed to protect against overloads and short circuits. An overload occurs when too much current is flowing through a circuit. This can happen if you plug too many appliances into the same circuit. A short circuit occurs when a live wire comes into contact with a neutral wire or a ground wire. This creates a very low resistance path for the current to flow, which can cause a large amount of current to flow very quickly. Circuit breakers and fuses are designed to trip or blow when an overload or short circuit occurs, cutting off the power to the circuit and preventing a fire. It is important to use the correct size circuit breaker or fuse for each circuit. Using a circuit breaker or fuse that is too large can allow too much current to flow through the circuit, which can cause the wires to overheat and start a fire. Using a circuit breaker or fuse that is too small can cause the circuit breaker to trip or the fuse to blow frequently, which can be inconvenient. You can find the correct size circuit breaker or fuse for each circuit in the electrical panel. The electrical panel is a metal box that contains all of the circuit breakers or fuses for the home. It is typically located in a basement, garage, or utility room. The electrical panel has a door that can be opened to access the circuit breakers or fuses. Each circuit breaker or fuse is labeled with a number that corresponds to the circuit that it protects. The label also indicates the amperage rating of the circuit breaker or fuse. When replacing a circuit breaker or fuse, it is important to use the same size circuit breaker or fuse that was originally installed. If you are not sure what size circuit breaker or fuse to use, consult with a licensed electrician. Before working on any electrical circuit, it is important to turn off the power at the breaker. This will prevent you from getting an electrical shock. To turn off the power at the breaker, locate the circuit breaker that corresponds to the circuit that you will be working on. Then flip the circuit breaker to the OFF position. Once the power is turned off, you can safely work on the electrical circuit. After you have finished working on the electrical circuit, turn the power back on at the breaker. To turn the power back on, flip the circuit breaker to the on position. It is always important to consult with a licensed electrician if you are unsure about any aspect of your electrical system. They have the knowledge and experience to perform electrical work safely and correctly.